That's my name. My name's Tony Kojundic. Just call me Tony. That's fine. We'll be cool. I know you guys don't have a real dedicated background in concrete, that you're in construction management, so you cover a lot of different aspects. So if for some things I get into in concrete that you don't understand, stop me. But I'm going to try and keep things that you as construction managers are going to run into out there, and the concepts behind it and the logic behind it and those type things. We're talking about high performance concrete, and to start I want to show you a little video here as kind of an introduction to high performance concrete. You may recognize some of the people.
World News Tonight with Peter Jennings continues. Now, solutions.
There are several ways to dramatize tonight's solution. We could tell you that a horizontal asphalt infrastructure anomaly is a curse for millions of American drivers at this time of year. That would be potholes to most of us. We could tell you that $52.5 billion a year goes to highway construction and maintenance, not to mention all the other money to repair the bridges and the other pieces of the nation's infrastructure. It is safe to say, we think, that if the ancient Romans were watching tonight, they would be asking, what took you so long? Here's ABC's Jack Smith.
Roads and pavements, bridges and support columns. All of what's called America's infrastructure is slowly crumbling because what it's made of does not last.
This is ordinary concrete, and this is what happens to it after years of punishment. It falls apart. Most of the concrete in the nation's highways and bridges has a life of just 30 years.
What's the solution? I'm standing on it. Brand new stuff called high-performance concrete. This is a sample. Engineers say this will last not 20 or 30 years, but 100 years, maybe longer. This is what America's roads and bridges could be made of in the future.
Engineers at the New York State Department of Transportation discovered how to make it 2.5 years ago.
We were surprised when we actually did all the calculations and got the test results back and said, my goodness, this really is going to work.
Researchers stumbled on the formula after the Clean Air Act forced power plants to reduce pollution. Huge quantities of industrial waste called fly ash began piling up, collected from smokestacks. At first used as a filler in cement, it turned out to be a key ingredient in strengthening it.
So this is 1/4 industrial waste. But it makes the cement many times tougher.
That's right.
High-performance concrete is 74% cement, 20% fly ash, and 6% microsilica, another type of ash, all mixed with water. When it dries, ordinary cement is actually porous, not solid. That's how salt and water get in. But the fly ash and microsilica are 10 to 100 times finer than talcum powder. And Professor Ken Hover of Cornell has found they literally fill in the microscopic holes in the cement and demonstrates it with colored tennis balls.
So the next thing I would want to do if I want to densify this box is get some mid-sized particles and take those mid-sized ones and try and get them into the box.
They fill in all the smaller voids in between the cement particles, and we just have a very, very dense material.
More waterproof?
Correct.
Stronger?
Yep.
Lasts longer?
Yes.
The new concrete is 3 times more water resistant, 20 times less likely to form cracks, and in pressure tests
9,060 psi.
has proven almost 20% stronger than regular concrete. However, modern scientists were not the first to make high-performance concrete. The ancient Romans were, mixing volcanic ash with their cement to make it far tougher. It's one of the reasons the Colosseum and other Roman buildings have lasted so long.
We really literally reinvented what our ancestors 2,300 years ago had already done.
At least 11 states are following New York's lead. High-performance concrete is more expensive than ordinary concrete, but because it's easier to lay down, costs about the same to use. Engineers say not only could it be an answer to much of America's infrastructure problems, but it could revolutionize all construction. Jack Smith, ABC News, Albany, New York.
That video was actually recorded February 11th, 97, so 6 years ago. They showed a map that only had a few states that have used high-performance concrete on their bridges. As of last year, all 50 states have used high-performance concrete on their bridges to one way, shape, or form or another. New York and Ohio were probably the first two guys to come on board full stream, where the fellow at New York, Don Streeter, was saying that that they had only come up with it back 2 years before 97, which was 95. Reality is they did their first overlays and bridges in the mid-80s. Likewise, Ohio, and then they looked at them, they watched them, they monitored them, they tested them, they looked at them for another 5, 10 years until they really got the data back, which what he was talking about. We looked at the numbers and they're really going to work out. They know they're going to get extra life out of these structures. In those two examples, New York and Ohio, they've been using high-performance concrete, that type of mixed design that Streeter talked about there, since 97 on all of their structures. There's probably 1,000 in both states that have been built, both overlays and new. And I say that because every state is different. What happens in Illinois doesn't necessarily transfer to what happens in Indiana, and likewise New York doesn't affect what happens in Pennsylvania, my home state. I'm ashamed to say that our state has 4 what I would call high-performance concrete bridges. And we've got New York and Ohio right next to us that have thousands. And, you know, the technology just doesn't transfer, which is part of what we do with the Silica Fume Association. As you see in the manuals that you have, the book was published by the SFA and the Federal Highway Administration. We have a contract with the FHWA to help them provide technology transfer to the various states. Since the states don't talk to one another, the feds have to effectively try and take you have to take the technology to, you know, Moses. You got to take the mountain to Moses instead of the other way around. If you work for IDOT, you only travel within Illinois. You don't go to Michigan. We don't have any roads in Michigan. Why would you go to Michigan? Even though there's a technical conference in Michigan that you may learn something from, you don't go there. So the technology has to be taken out, which is what we help the FHWA do. The federal government has cut back so much on their field people that now they've reached out to industry like ourselves to help them with the technology transfer. We don't want people to reinvent the wheel. There's no need for a state to put down a bridge deck and watch it for the next 5 to 10 years. The Federal Highway Administration, as we'll see here, recognizes the benefits of using high-performance concrete versus how we built our interstate system the first time. You saw some numbers on there of $52 billion. That was $97. The last the last Congress authorization for funds was $318 billion for all transportation systems. I think like $100 billion of that was for bridges. But today we're going to talk about high-performance concrete in particular. Let me see if we can bring all this up here. Thanks. No problem, no problem. Straighten out the projector if you would. What is high-performance concrete? One of the performances we think of is strength, high strength, easy to measure. You make cylinders, you cure them for 28 days, you test them in the laboratory, you know how strong the concrete gets. Normal concrete, sidewalk concrete, highway concrete, 4,000 psi, 28 days. That's how long it takes for the concrete to change from the mud in order to get hard and develop some strengths. You see a lot of high-strength concrete on high-rise buildings. This is 311 South Wacker. When it was built, it was the tallest concrete building in the world. There's since some other ones. They use high-strength concrete in the columns of the buildings. If you think about it, it stands to reason. If you were to make this column out of 4,000 psi to support this weight, the column would become very large to support that mass of weight on there, the dead weight. If you make this column 12,000 psi with a higher modulus of elasticity, the column can become a lot smaller. Not less is the column smaller and you're using less steel, but now if you've got 20 of these columns going up through the whole building top to bottom, and you save 35% square footage on every column times 20, they lease the building based on square footage. So if you can reduce that column size, if there was no columns, Donald Trump would love it because then he could rent out the whole floor. So but the idea is to make the columns as small as possible with as high strength as possible, and then it gives the owner something more to rent, to lease out, and they make more money off of it. High strength in Chicago, 12,000. Right now Trump Tower is going in at 16,000 psi concrete. They have a modulus of elasticity. They actually didn't require strength. they required a certain modulus of elasticity out of the concrete so that the building would stay rigid enough. They have an equation where if you live on the top floors, you can't feel the building sway. I think it's like one time in 30 years that you should be able to feel the building sway. And they go from that measurement back to how strong the concrete has to be in order to keep the building that rigid in the 200-mile-an-hour winds that they get in Chicago sometimes at those elevations. So it's a crazy calculation, but they're up around 6.6 million modulus of elasticity, which is really high. That's just one property of high-performance concrete. The FHWA says that high-performance concrete is a concrete in which certain characteristics are developed for a particular application and environment. And the operative words there in the sentence being certain characteristics. Concrete can have a lot of different characteristics. High strength is one. Right now, in the construction industry, one of the big things in concrete is art concrete, stenciled concrete. You have some pavements out here that are stenciled to make it look like bricks. It's actually concrete. They throw colors on it. You go to some hotels, they'll have the drive areas to look like specialized stones with colors on it. That's actually a high-performance concrete. They're doing something other than making a gray slab on the floor. They're getting something out of that concrete. Here's a list of what the FHWA says are some of the HPC characteristics. It can be ease of placement. You ever heard of self-consolidating concrete, SCC? That's probably the latest thing in the last 5 or 6 years in the concrete industry. They've got certain chemicals, and silica fume can be used for that application, but they're able to make a concrete that flows like water, but it doesn't separate from the aggregate. The aggregate and the mortar and everything moves in unison. So, you know, normally, anybody work with concrete? By hand, actually wheelbarrowing it and putting it in, or what type of work? Actual finishing? Okay. You know how heavy it is to pull the concrete around. You know, it's back-breaking work to do. SCC concrete, particularly in a precast plant, where they're filling up concrete in forms, or even in houses where they're filling up basement walls. SCC concrete, they can place it at one end of the form and let it flow like water to the other end of the form, and the aggregate will stay with the leading edge of the flow.